all of you would enjoy this particular thought-provoking session. Today our speakers are two students actually. First one is Sayan Mondal. He is currently pursuing his final semester BTech CSE. And another speaker is Somyajit Chakraborty. He is also pursuing his BTech. He is now in fourth semester. Both of them are from Techno India University. Some of them might be here from different university also. So I'm mentioning this particular thing. So without delaying much more, let us listen from the speaker. So Sayan, I'm basically handing you over this particular talk. So let us start.
Okay.
So thank you for joining this particular session.
Okay.
So let us listen from Sayan first. Okay, thank you.
Thank you. Good morning, everyone. And thank you, sir, for handing me over the mic. At first, I request everyone to please mute all your mic. And then, so can I start? Okay.
You start.
Okay, thank you. Today's our, wait. 1 minute. Today our topic of discussion is text summarization, and we will discuss about from very beginning to little more bit at first. I am Sayan Mondal and founder of Bread and Code. The initiative is a collaboration of Team Bread and Code and Department of Computer Science and Engineering, Techno India University. So I like to thank both for giving me the chance to present the topic in front of you guys. So let's start.
Hello.
Hello.
Hello, Sayan.
Please unmute your mic and video also. Thank you.
I will mute the video.
Mute the mic. If you want to ask any question, please raise your hand. Then.
All right.
Thank you. In this new era, where enormous information is available on the internet, it is most important to provide the improved mechanism to extract the information quickly and more efficiently. Everybody knows about summary. From our school life, we are writing summaries of long text. But now, in the era of internet, it is when billions and trillions terabytes of data is available, it is much more important to us to extract what is necessary for us, to identify what particular information is useful for us. And in this case, the summarization is maybe helpful. Summary means rewriting any text or document in short, containing only the most important points or key aspects of the original text or document. Thus, idea of summarization is actually very old, and it is seen in different cultures. Like in Egyptian hieroglyphics, they represent each long sentences as a small picture. Now, when we have a lot of information or large document of text, so there is a problem of searching for relevant documents from number of documents available and absorbing the relevant information from it. In order to solve the problem, there are automatic text summarization. There is a need of the text summarization system. The text summarization process or automatic text summarization process in computer is widely known as a part of computing called natural language processing. So, what is summary? Before going to the text summarization, first we have to know what is summary. Summary is a text where product from one or which is produced from one or more texts that conveys most important information in the original text, and it is in shorter form. Text summarization is a process of identifying the most important, meaningful information in a document or set of related documents and compressing them into a shorter version presenting its overall meaning. So basically, we know from our childhood what's the basic rules to writing a summary. That is, number one, read it and understand what's the document owner to convey its meaning. And if possible, we should take notes. Then we have to identify or underline the most important points. Then write our summary from the notes. Then check the summary against the original if there is any conflict or not, and revise, and we have to correct the summaries that it have the most it has any error or not, and if there have any errors we have to correct it out. But so whenever we in our daily life we can see the use of text summarization in various forms. There's whenever we saw any news, we have the news bulletin headlines, or in a news channel, they have headlines conveyed in the below side. Or outline, whenever we're taking the notes, sometimes we highlighted some points. That is the most important feature of a document. Or whenever we're attending a meeting, at the last we have to submit the minutes of a meeting. They'll also have some preview of a movies. It can be a review of a book, CD, movie, etc. The review is easily available when you open a online book shopping cart as Amazon or any good readers. We can see some information about a book. What is the main topic of a book it is written on shortest form. That is an example of summarization. They also have digest for TV guide, newspaper bulletin, sound bites, and histories for chronological or silent events. Apart from that, natural language processing is the driving force behind following common applications. In our day-to-day life, we are using OK Google, Siri, Cortana, Alexa, and many more PDA or personal assistants or voice assistants. They are using natural language processing, and they are also have some kind of short summarization in built using Google. As whenever you ask your Google, okay Google, say something about any topic, it will say some highlighted topics from a long blog or a Wikipedia journal. That's use of text summarization. There also have some we can use it to create the abstract of research papers. That's there. If you have a long and if you have lots and lots of scientific research papers or a only one paper, you can take our multi-document or single documents. The text summarization is maybe useful to produce the abstract part of the research papers. It also enhances the product quality by processing customer review. In Amazon, Flipkart like companies, they have to face n number of review, n number of comments from customers, and that is to a big company that is impossible to read each and every one comments. That there will also be some repetition. There are also some fake news, fake something. We have to remove this, and using this, it can review a product review or product uh, ratings. So, in computational science, now what is the summaries may be classified in two parts. One is abstractive, and other one is extractive. Extractive summaries. As in our school life, whatever we are writing, we are reading a text and writing it's the key point of this text from this text. That is the extractive summaries. The extractive summaries are created by reusing the portion or using some sentences, using some words of the input texts or whatever the documents we have it feed into a system. As the search engine generally generated the extractive summaries from web pages. And still now, from ancient age, whatever the research is going on, all is depends on extractive summaries. Up to 1999, if I am not that much wrong, there whatever the research has been done, these all are taking the key points. It all are identifying the key points from a text document, from a feeded document. Is a feeded document is using their own sentences, using their weightage and other languages, as so that is using reusing the sentences, that is called the extractive. And in abstractive summaries, we read all our document. We have to understand what is the meaning of the document, and then our output sentence have no similarities as with the text with the main source document, source code. So in the abstractive summaries, we identify and rewrite or rephrase our idea and generate our outputs, generate our output summary. In abstractive summary, information from the source code is referenced. The human being generally write abstractive summaries that whenever you're writing a summary, you are not reusing the sentence, which is necessary that you should not reusing the sentences uh, from your text from the main text page, but expect we are copy and paste when our assignment. We never do this. And in abstractive summarization has not reached a mature stage because there are also a lot and lot of problem as semantic representation, interference, or natural language generation, and relatively harder. Sometimes we can't identify the key languages using our existing system. Sometimes it is too much hard to us to rearrange this on the proper way or identifying the weightage of system. There may be a very short sentence that is very negligible, but it can hold much more impact in the paragraph, in the documents. Sometimes our existing system using automation, it may be remove it may be ignored it. So there have lot of problem, and we will discuss about the problems later also. So whenever we have sentences, there also have some procedure or some process to how to work on it, how the system is working. We have a text document. Then the text document contains lots and lots of unnecessary information. To remove the unnecessary or unwanted sentences, we have to make it we have to pass it through a text preprocessing phase. In the text preprocessing phase, the comma, semicolon, it is the unwanted punctuations, some A and the this kind of phrases will be removed and it produce much more solidified text. Then we have other text, it is called POS tagging and tokenization. Then we have to break our each sentences or each document into smaller part. That is called tokenization. And after tokenization, we have to complete the POS tagging or parts of speech tagging. We have to identify what kind of phrase it is. What is it is a noun, pronoun, verb, or anything else. And then we have to labelize this. The next 3 points as is calculating TF-IDF score for noun or verb phrase, calculating sentence score, and choosing the most important sentence on basis of the information. The 3 parts differs from algorithm to algorithms. In this presentation, I just preview the basic of the procedure, but it may differ from events. So in a basic statistical model, we have to calculate the TF-IDF score, and then on basis of this, we have to calculate the weightage of sentence and then produce the most weightage sentences at my input, and then merge them and produce the summary of it. So first point is our preprocessing after starting with our POS tagging. Before POS tagging, we need tokenization. That we have a long sentences. Words are flowing out like endless rain into a paper cup. Or they are also with a second sentence, they slighter either they pass, they slip away across the universe. There are two sentences. The main motto of the tokenization system is is running a segment between the sentence and words, and then it starts is cutting the sentence into very small part. If it is a sentence, the smallest part is word. So, in the phase of tokenization, we define the each sentence into words. After that, we if we want, we can remove some certain words that there are number of a, there are only one a, it is unnecessary in our summary. So we can remove such words. If there are a lot of D, we can remove the D from our summary. So this part can be helpful to identify which is should we keep or which we should throw away. After, also in languages like English, there are also some separate words by a blank space or something in our local languages. There also have some unidentified or undictionary word. This also can be removed in this phase. Then we have other important topic is POS tagging. After tokenizing or after dividing a sentence into very small part, we have to identify what kind of part it is. There is an example sentence as I want an early upgrade. There is I. In using previous speech as tokenization, I divide that long sentence into 5 parts. Part 1 is I, part 2 is want, part 3 is and, part 4 is early, and part 5 is upgrade. Then, in the POS tagging phase, we have to identify what kind of parts of speech each part is. That I is pronoun, want is verb, and is determinator, early is adjective, and upgrade is a noun. So, using this verb, if you want to remove the determinator, we can remove it. Using the pronoun, we can identify which person it is referring to. In our summaries, we normally we never use the pronouns terms or determinator term or adjective term. So we using the POS tagging, we can identify which the words we should to remove or which the word we that are unnecessary. So POS tagging has normally two steps. The first stage, it uses a dictionary to assign each word and list of potential parts of speech. And second stage, there also be large list of handwriting notes or rules which should down as a single parts of speech of each word. So in the first stage, how we can identify that is a pronoun, that is a verb, that is a determinator, that is adjective, that is noun. There are lots and lots of dictionary, lots and lots of predefined set of words that if we have identified these words from the dictionary, we can get what kind of your parts of speech it is, and we can tag it. And apart from that, we also can write our own separate rules or own separate filter to identify what is the most important word for us. That the dictionaries are written for basic English, but sometimes we are going looking for some specific English term as computer science in English or computer science terms or physics terms or chemistry terms. So for these terms, we can write separate own rules, own set of filter, and based on this, we can tag each and every process. After that, we have to apply our different algorithm to 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 represent our topic, to shorten uh, shorten our text, shorten our tokenize, and produce a main form. There are 5 to 6 main approaches, and apart from that, there also have other approaches. So first approach is frequency driven approach. They also have cluster based method. They also have machine learning approach. They also have text summary using neural network, and some fuzzy local based system, fuzzy automatic systems, and many few more. So we are going to our topic, frequency driven approach. Frequency driven approach is the oldest method to identify the identify the most important words. It was developing prior 1940, 1950 times. So in this term, they are whenever we think about a document, they are also have lots and lots words repeatedly. That's some pronoun. That's some specific words. There are also some verb we repeated use once again and again. So using some statistical method, we can specify we can get each and every sentences and calculate the frequency of each sentences. After that, when we get all the frequency of the words, we can sum up. We can take each sentence and sum up the all frequency of the text. Then, depends on this, we can identify what is the most important word for us. It is a comparison between frequency in the document in case each sentence is treated as a document and the document frequency df, which means the number of times that the word occurs along all the documents, and the df by idf of word is document number into log of 1 plus df by log of df. That's the basic formula. So what it did, that I think in a document we have only 10 sentences: A, B, C, D, E, F, and others. There are B is the biggest sentence, B and C, and other sentence is smaller, A, D, E, and F. B or C sentences are containing most of the most frequency words again repeatedly. So if we sum up the frequency per sentences, we will get the most frequency for B or more C, and then A, D, E, F, and A. Using these approaches, it will take B or C as the most meaningful or most statistical system or what. In the example, we can perform a text or we perform a script to solve this problem. In the text, there also have a old story as Midas and the gold. I hope everyone knows about the story. And I run the sequentially driven approaches on this text. So you can see there are Midas, his, he, and wish, gold. These words has more frequency, and the smaller words in the blank figure 1, smaller words has less frequency. So the words is written very smaller format, and if you can zoom the terminal, you can show it only represented 2 words as its summary, but it is not. It can't convey the main meaning of the summary system. The next approach you can call is called cluster-based approaches. So, what is cluster-based approach? In cluster-based approach, we have topic modeling. A document can have different topics. So So, using cluster-based approach, we have the topic representation of a paper based on C-score, some ranking methodology as text rank, C-score, SWD score, and etc. What is this? There are document collection which summary is to produced and is of totally defined topic. Defined clustering becomes almost essential to generate a meaningful summary. Sentence selection is based on similarity of sentence to the theme of the cluster. The next factor is to locate of the sentence is document li, and last factor of the similarity is first sentence document which is belongs to fi. So the similarity is calculating using wi into ci plus w2 into fi plus w3 into li. To clustering we can apply k-means. What we did, every word is related to each other. In that you have a cluster-based approach example that if you think about Sunday, Monday, Tuesday, Wednesday, these are the name of day. So when you take a day, we have it's seven other graph node that is connected with a Monday to Saturday. If we think about the months, January to December, the month cluster will be concentrated with January to December. And if we think about some year, it will be shows. If we think about a historical document and there are some year, the year will be connected with a time year and 1990 and 1990 apart from that color, apart from that we can based on some arm, some body name, some person name and model this topic. They are also be investigate. They are also an interesting topic and is called topic modeling. The topic modeling and the cluster-based approach uses the topic modeling to define the each and every words based on its frequency models and estimated the word or estimated the result word. For this, it can using the basic clustering approaches that's called k-means. Next, we are talking about the machine learning based approach. The training dataset is used to reference and summarize process is modeled as a classification problem. Sentences are classified as a summary sentence and non-summary sentences based on features they process. The classification problem are learned statistically from the training data using Bayes rules. If we have a dataset from with dataset and using a score or C score or topic modeling, we can identify what the features of the documents have or what kind of the labeling the documents have. So, if it's so, the summary is probability of summary is based on P of S1, S2, F3 or frequency equal to probability of frequency into its the probability of sentences by probability of frequency. That is basically a Bayes rules. Next, and up to Bayes rules, all of the modeling, all of the text summarization model are basically basically reuse the reuse the phrases from the text. Then, if we want to regenerate our sentences, regenerate some new sentences, or understand the topic, we have to move our today's model, that is the fit model, that is called neural network based. Using the neural network based model, there have number of layers inside our neural network, and then if we pass the sentences, it will identify exactly the token, exactly the fit features, and then it has by searching the internet, by searching by reformatting the words and by searching other sources, it is able to reformat or reconstruct the sentence in new form. So CNS is formulated for the data processing in form of multiple arrays. Whenever we passing some data, or words or sentences, the CNN structure is uh, is break down it into some numbering form. Then the numbers from will be will be manipulated and will be fitted into some array. Each token will be treated as a room as a column or rows of these matrices, and after that it will the word will be converted to the matrices, and the matrix will be formatted into the next step. There also, and then it will combine the local feature and then it and output, and then send the output as a combined local of the local features to one of to in the in natural language field. The model is called sequence to sequence. Is basically used for basically used for natural language for encoder decoder model and natural language model. NLP is used to convert sequence from type A sequence to type B sequence. In the example, you can show I have a sentence that how are you? The sentence will be fed into our embedding layer, and then it will convert it to sequence model, and in the decoder layer we will represent as the answer that's I am good. The recurrent neural network is based sequence model have generated a lot of transaction over since they have introduced in 2014. Most of the data in current world in form of sequence. It can be a number sequence, it can be a text sequence, it can be video frame, or it can be an audio sequence. The sequence model, the work of the sequence model is produce a different sequence from a given sequence. So how it works? Basically it works on encoder or decoder model. The encoder part is responsible for stepping through the input time and steps, encoding the entire sequence into a fixed length vector. It is called context vector, and it's sent to a decoder model. And in the decoder model, it reads from in the decoder. What is read take the input from the encoder and present the new sequence in output as a context in form of context vector. So to form or to form the uh, new sequence or to transform the encoder or decoder system, the system is using the LSTM or long short-term memory. So what is basically the long short-term memory? Long short-term memory is if a system is fed with a random address or fed with some continuous type of information, the long short-term memory is able to memorize what's happening up to the next time. It is something like comparable to our dynamic programming type system that whenever the operation is done, it will remember what the output of previous steps. In a LSTM cell, we in the LSTM cell, we have the RNN or the recurrent number. The input is fed into the cell against and against. If the LSTM is have its own mechanism to control it, sometimes if it want, it can. Sometimes if it want, it can remove some information. It can add some information by its own. So if you wanted to learn more about it, can be other topic. And then we are talking about some reinforcement learning. What is reinforcement learning? Reinforcement learning is a sequential markup decision process or MDP, which is agent contracted to environment and over distinct time step T. The reinforcement learning M is represented as S, A, P, R, SO, Y, and T, which is discrete finite horizon uh, discounted markup decision process, where S is the set of state, A is the set of action, P is S into A into S, that depends on the state and action, and it will be represented as transaction probability. It can be identified using the simple image. Let's we have three states as S0, S1, and S2, and we have to browse from S1 to S2. Using the reinforcement learning markup model, we can say that the pathway from S1, S0 to S1 is directly dependent on this path, but it says that it depends on the probability of the specific steps. It can be from S1 to S0 through A0 process, through A1 process, or A2 process. Depending on the probability of each condition, the output or the outcome result will may be difference, or it can be, and that is a basic reinforcement learning algorithm that which states if we input some batches or some batch of result inside it, and if we can some result inside it, and it will train again and again full sequence, and if and okay, if we can, if we result inside it, and it will treat it as the continuous result or continuous performance based on reward. And if the state has some good points, it has state has some specific reward, or it can state if the state is able to reach on the specific state, we can also add some rewarding points. So reinforcement, using the reinforcement learning, we are basically using the Q network. Q learning network is a policy. Basically, this is a policy for our reinforcement learning. And what is the rules? So the basically the rules for the Q learning is optimal policy for the decision process. It approaches the action value fraction. That is, you have if a position or if a point can reach in a certain point, certain state or certain utility factor, it will be dividing it at a it will be rewarding it a plus point, or it will be rewarding it a minus negative penalty point. So basically, what is this? That if you can consider that is a game, and the robot have to reach the end point. We only have four moves. That is the upward, downward, and sideward. To sideward. So what is it does? That the robot has to cross the bridge and reach the end point. There are mines. The robot can only move one tiles at a time. If the robot steps onto the mine, the robot is dead. The robot has to reach the end point in the shortest time possible. So the robot loses 1 point in each step. So what is the rules of game? The robot loses 1 point at each step. It is done so that the robot takes shortest path and reach the goal as fast as possible. If the robot step on mine, the point loss is 100 and the game ends. If the robot gets some power, it will gain 1 point. And if the robot reach end goal, the robot will get also some rewarding point. Now, there are some questions. How we train the robot to reach the end goal with the shortest path without stepping on mine? To introduce the problem, to solve the problem, we introducing some Q table. Q table is something simple lookup table. Here, the rows are the action, and the columns are basically the outcome, or basically the possibilities of the state. Basically the process. So if the robot move to the down left side, it will be the state start will be action as 1. Then it should take the down side to, and then the action will be treated as 0 to 1, and then and that way we have to convert the table into using +1 +1 +1, and after that we have to convert, or we have to upgrade our table up to when the robot reaches at the end point. So, what is a Q-learning? Q-learning is basically statistical hypothesis testing, specifically multiple hypothesis testing. The Q-value provides a mean to control the positive false discovery rate, or PFDR, just as P-value gives the expected false positive rate obtained by the rejecting the null hypothesis of any result with an equal or similar positive value. The Q-learning values give the expected PFDR, or positive false discovery rate obtained by rejecting the high null hypothesis for any result with an equal or smaller Q value. That's why we have to that is the reason. That's why we have to find the optimal and shortest path to reach at the end. Now came back our reinforcement learning. What is the Q value, or what is the state of art of the reinforcement learning? That if we stand the state S0, and if we want to go to the stage S2 or node S2, we have some certain condition as A0, A1, A2, and so on. If we start our movement from A0, we have to face A0 or A1. We reaches to A1 is completely depends upon A0 or A1. So that is if we have some positive or +1 rate or +1, we can reach it, or if we have to dodge it, we can be in loop. So the problem can be solved using the Q-learning. Apart not only this, but in text summarization we have deep Q-learning model, double deep Q-learning model, and so on. What is the sequence-to-sequence model? The sequence-to-sequence model in text summarization is basically using on this tab. So sequence-to-sequence model is text summarization, headline generation, machine translation, or question generation. So that's why we have to take the policy of attention-based model, pointer, generator, etc. So action will be selecting the next token for the summary, headline, and translation. For this, we can use a rough score, value score, etc. Sequence to sequence can be performed as a question answer questioning or answering. It can be a policy as a sequence to sequence model. Action will be selecting the answer from a vocabulary, or selecting the start and end index of the answer in the input document. It can be done using the F1 score. And the two is not topic of today's, but sequence also can use in image capturing and video capturing. Apart from that, in NLP part, it can use for the speech regeneration and dialogue generation. Jobs all can be done using the value, length of dimension, diversity, CTC model, or temporal classification model, anything. What we did as of now, we have what we did. Whenever we wanted to explore the NLP features, or we are going to explore some new models using NLP, we have to face a lots of problems. One of the problem is whenever we're getting the data, there also have some lots and lots of unnecessary data, or these are called noise. One of the problem is removing the noises. And when I was talking about the Q networking problem, or when I was talking about the attention mechanism, there also I said there's a self-attention mechanism. Our work is to build some unique kind of self mechanism which is able to run itself and relay on its own rather than other ground truth to generate the result. It means our model will be able to generate the document summarization at its own without providing some predefined dataset of documents. Apart from that, we already built some automatic token generation model. It is called Easy Token, and S Atomic is a new atomic new attention type mechanism to new attention type mechanism to identifying the uh, it's identifying the shooting system. Now I'm switching to Somyajit. If you wanted to say something.
Yeah. Okay. You stay the host. You just take the PPT again, please,
Sure.
in our problem statement.
Okay.
The problems. Yeah. Hello and good morning to everyone. Actually, it's afternoon. We're past 12. So I'm Somyajit Chakraborty, Department of Computer Science and Engineering student, second year. So what we are doing. So my friend and co-researcher Sayan Mondal has already gave a great deal of insight on the topic of text summarization and what are the state-of-the-art models currently there. So the major problem that we face is obviously in terms of data. See, the data, the training sets are not always available. The data is quite random. Most of the summarization which we do, if we go into the deep sense, most of the summarization, it's a lot of, for example, the documents are huge. And, since the volume of the documents are huge, the volumetric amount of the data is huge. So there is a problem that the ground truth, or what is ground truth? The ground truth is the training values. The training values remain just the same. The testing values, the ground truth testing values remain same as the training values from the previous training models. What I mean to say is, after training a single model, after we train the model, the output we get, from that output we again train the model to make it better. That has its own problem. See, the first problem, the exposure biasness problem, that is a huge problem faced by NLP workers. So we have to, our model, what we are working on is to negate that problem. And another huge problem is the noise. Not all noise, presence of noise it is there everywhere. It is even in uh, picture analysis, in computer vision, it is in text analysis. So the noise is something like disturbance or the wrong processing. For example, in tokenization, there are certain problems. For example, a name, for example, a name such as San Francisco is separated by a gap. Now, San Francisco together means something. Individually, they don't mean anything. So that is a problem. So in tokenization, it might happen that tokenization is done in such a way that San is taken as a singular unit and Francisco is taken as another singular unit, which is a problem because they don't mean separately anything. So these are some noises there. Another example, another huge problem is with the stop words removal. In case of stop word removal, for example, full stops or punctuation marks, sometimes it happens that you see doctor dot, we always writes in a manner say doctor dot or Mr. dot. Now that dot means something in doctor, in these abbreviations, they mean something. But when we remove the stop words, they also get removed. And therefore the meaning, when we perform topic modeling or clustering techniques, these models, in these models, these words, they don't actually mean anything after removing those punctuation. So these are noises which are currently we are dealing with. Many computer scientists are dealing with these noises. Many researchers in this field are dealing with these noises. Now, our model, our work is basically a self-attention model which relies on an RNN model. We are using the reinforcement learning Q network model. But the main difference is what we have found out, that by changing the nature of the attention layer in our RNN, we can actually manage to negate. We cannot completely negate these problems, but we can manage to get better results in terms of statistical analysis. For example, the one of the good grading system is the rogue grading system, which has been seen in previous images, rogue grading system. So in that sense of grading system, the grading scores are much better if we change a bit of our attention system, attention mechanism. So we can reduce these two problem statements. So these are our problem statements. These two problems, we can reduce considerably these two problems. So, okay, next slide.
Okay.
Yeah. So we have changed two key aspects of our model. First is the tokenization process. We have created an alternate auto tokenization model known as the Easy Token. It's a library, open source library. Anyone can download it. It's PyP registered. And we also have the SATMAC, the separate attention mechanism. Now, it's a self-based attention mechanism. What difference? Mathematically, if you want to understand, the difference are in the hidden layers. The hidden layers, the attention scores, we provide these scores on the basis of a different score function. So we have changed a bit from the scoring function which is present, which was introduced in 2019 actually, by his name is from Go Hun. So he's from Indonesia. So he actually introduced this model, scoring system model, attention equation. So we have improved that attention equation to find out that this only helps us in understanding why this.
Hello.
The noises and the ground truth, the training, the problem encountered while training, those two problems, why they happen and how can we reduce them. So our attention mechanism is a modification over the model introduced in 2019. And also the Easy Token, it's a brainchild of Sayan Mondal, and SATMAC is developed by me personally. So we both combine these two methods to form a text summarization model, which is much more accurate, in the sense that obviously machine learning models, we are talking about machine learning models here, all depend. So obviously we cannot get a great deal of accuracy from that, but we are considerably accurate in terms of previous rogue scores and previous scoring system. We are considerably accurate. So yeah, okay, Sayan, you want
Yes.
to take over?
Okay, fine. No,
Yeah,
that is completely okay. And apart from that, we also have identified some field of research in the field of NLP, or natural language processing, that actually, in terms of the automatic natural language processing, by regenerating the sentences or regenerating the full word, full documents, it is completely new, and basically it is introduced at 2014 by ethnic. So here is an example that I just grab all the data from Wikipedia and use, and by running our methods, we can find out the key point, or we can find out the best similarities about the London city in this. So here it is an example that you can get only
Uh,
10 to 12.
okay, Sayan, one thing just I want to say.
Yes.
Yeah, so this you see the Wikipedia data we use, the Wikipedia data, the page from the Wikipedia data, it has been used in earlier papers for grading. So that's why we chose that data set particularly, because we can compare our work with the previous models prevalent, because they have also taken the same data set. So in terms of that, we have a better accuracy. So that is okay, Shayan, you
Okay,
say.
okay. So you guys can see that they are also only to a 10 to 12 special fact, and that is the main summarize of the full long London Wikipedia pages. And it is completely based on the CNN, and we already had only 7 to 8 days of training or running of the model, and then it can be better model. Apart from that one, what I was talking about, that we can identify some key points or key aspect on which you guys can research, or which are completely new or not that much developed in the field of natural language processing. That is, one is in extractive summarization. What is the choice of encoder or decoder? What type of encoder or what type of decoder we have to choose? Or what is the relationship, schematic relationship between the sentences? What is the most useful part? What will be the what we should to remove? That to developing that thing, to developing this part of it, so that is most important. Apart from that, out of the vocabulary words in abstract summarization automation, they are also have lots and lots of slang. They in the books you can get a lots and lots of slang, lots of local words, lots of few other words which are not in that much vocabulary, that's which are not in vocabulary. So to finding out to identify the out of the vocabulary word is a big challenge. Apart from that, we have to improve abstractive the existing system, which is always welcome. In comprehensive summarization, how to how we can define a scoring function. Previously you can say about the C score or any other statistical scoring function, but it may be defined from this statistic model to model. So what should be our perfect model to score the function? What should be the number of source documentations? And yes, so that is the problem. So, and that is the problem, that is a single document or multi-document fundamentation. Nowadays we are okay with to document or to make a summary of single document, but it can be a data set of research, on NLP. If we are going to start, we are going to take a take a brief from all of the NLP models. So we have to make the summary of a long data set. Long, not there are to be thousands and thousands or millions and millions of data. There are data documents. So single document or multi documents summarization, these are two defined problems. Then you have to evaluate how to create a new data set. What will be our new data set? What will be our most important feature? To identifying the features is also a great technical research problem. So, and also have the learning method. What the method we have to take it? Why supervised? Why unsupervised? If we want to build a data set, on basic of what we can build a data set, what the most key important features of the model, what would be most important features we have to looking for in the document, the identifying the state, the uh, identifying the unsolved mysteries also can be a good research paper, a good research problem. Apart from that, we have also multilingual or multi-model. They also have nowadays most research is working on the English language, but they also have lots and lots of other local language, Bengali, Hindi, Tamil, Telugu, etc., etc. We have to perform the linguistic operation on this topic on basic of what, on basic of which aspect we have to perform our operations. That's the new problem. Apart from that, we have summary of programming languages. There are lots and lots of programming languages as C, C++, Java, Python, etc. And whenever we are going to digital era, the uh, the computer coding, the coders have to write a lots and lots of page. how efficient these are. The coding is whenever you knows about whatever you are guys knows about the coding, that is basically English languages, and that machine is translated into each machine code. That how what efficient the English language is, how efficient the language of coding is. That is a summary of programming languages. That is much more important topic. Argument mining or query based summary, that's also important. That's we have to identifying some chatbot type of system or question answering system or based on NLP system. So we have to identify what is we have to answer the all questions correctly. We have to identify what the argument we have to fill down out, what how to answer a question on different way, on with personalized way. These are the topic which are nowadays that is little bit untouched on the NLP field. On other fields, these are too much advanced, but in this field, these are not that much in front line. So if anyone guys they can working on any of the topic and you have a number of titles. So as of now, I have to wrap up all our presentation. So thank you, Brain Lab, the Brain Behavioral Research and Information Networking Lab that's under guidance of Professor Avijit Gayen. Thanks you again for attending.
Sir, you want to say, sir, Avijit, sir, you want to say anything about brain?
Anyone have any question? Or
Yeah, Shan, it's a wonderful talk, obviously, and definitely a thought-provoking also, and definitely everybody also enjoyed a lot regarding this particular discussion. And I want to say means definitely we will take this particular theoretical discussion on regarding this each and every text summarization processes or everything regarding the theoretical process, but it would be better much more for those who are actually the newcomer, those who are coming in the very beginning stage. If we talk from the next session much more regarding the application oriented, means on the first of all some portions regarding some applications, what exactly means, so that first they can relate with their real life problems, and then we come to the theoretical part. Then it would be much more better, much more vivid it would be. That's actually my suggestion.
Yeah, that is. I thought to present some practical exam, but for short of the time because of the lack of the time and the longevity of the process is, can't be possible in short time of meeting. So that's why I will look into the how it can implement a theoretical and apart from the practical model to be consumed on the next sessions. If anyone
So in near future probably we will be again arranging some this kind of webinar once again, and the people will be joining definitely if they are interested to learn in that way of this particular way of learning is also very good. So from the next session we'll be planning on the much more of particular application oriented, and specifically a particular means not a whole thing will be over there, but some part of thing will be much more focused. Like say for example we can discuss on a particular topic. Say for example people might be interested to learn what is LSTM. Okay, that is also very interesting one. Okay, so what is the use of that, how it could be used. Okay, so those things will be coming much more important to them. So so we can arrange near future in that way our this talk session. Okay,
of course.
Okay, thank you.
Okay,
Thank you, sir. Okay, anyone have any questions regarding the discussion we had about the topics? So you can start.
Hello,
Hello.
can you hear me?
Yes.
Yeah.
I had a doubt regarding you were saying about the two problems that you faced. The one is the exposure bias and the second one is the noise, right?
Right.
Yeah.
Yeah, I mean, I have a single doubt. Can we not eliminate this problem of noise using n-grams or bigrams? Hello.
Hello.
Hello, I'm Somyajit. The same question.
Yeah. Yeah. Okay. So
So we can
about
also use.
n-gram models, you want n-gram models to reduce the same problem. Yeah, right. N-gram models are is a good alternative, but see, there are certain problems with it. The computational power, and generally, if we are dealing with sound, when we are dealing with speech to text, then we can use n-gram. N-gram is better for speech to text, but not particularly for text summarization. If it's an entire textual data, then textual noise cannot be eliminated in a better way by implementing n-gram models. See, n-gram models are better suited for sound data sets, which are that is speech to text transformation. For that, n-gram models are better to cancel noise.
And basically, what is done in the n-gram models. N-gram models is basically works on the sequence and notability of the natural language processing. So whenever it is going terms about the sequence, so in the text or in your speaking language, the sequence may be different. A sequence can be defined from each one, and so in this case, we have the lots and lots of data sets. So, but we can build the dataset from it. But in terms of the self-adaptability, we doesn't require a long dataset, or it doesn't require a predefined dataset for it. So it depends. So that's why n-gram is not that much in front line to
Suited. That's much suited.
suited for the
Text summarization
for self-attention. For
self-attention or
self-summarization
or any kind of any kind of text-based summarization
Yes.
in the matter.
I have a question. Can I speak?
Yeah, obviously.
Yeah.
You're open to
Yeah.
question.
Actually, during topic modeling, I think has been mentioned. So, what about the context analysis? I mean,
Yeah, topic modeling, contextual analysis. That part that is another important part.
I mean, we can use skipgram model. I guess.
Yeah. Context, that is a current research. We are actually also, that is also a part of our study. See, the contextual analysis is a very open field, and it is still now there are researchers working on contextual analysis, and that can be attained by topic modeling. Yeah, right.
I mean, that is a basic requirement needed for text summarization. So that's why context is very important.
Yeah. Sure.
In context modeling, I wanted to add some points that in context modeling, n-gram map is one of the basic fundamental for the context modeling or context analysis. But it in terms of regeneration, it is not that much possible system.
Okay. Thanks. Thank you.
Any more questions?
Hello, this is Biresh.
Yes, sir.
Yes, sir.
Yes, I wanted to just ask you, is this entire project mostly targeted towards textual data?
Primarily we are targeting the textual data, but we are also working on producing a content-based summarization. That is, everything should be covered on that content aspect. We are also working on the pictures, so that we see in documents there are not only text, there are also pictures. So which pictures are relevant? So that is also we are working. So primary objective of our project is first we perform text summarization, and then with the same model in a much more larger way we perform content summarization.
For example, if let's say take the example of stock markets, how the stock prices move. That's a pretty vast amount of data, of course. I mean, any stocks which are there on the market for some time, you will have data for them. So you can train based on that available data. You need stochastic models. What kind of models do you use? In the sense, do you use some kind of mathematical model, like representing it in a what do you call it? In some kind of how do you design the model? How, in the sense,
It
is it some kind of like market factors, risk factors, 2 3 models, like sensitivity for this, sensitivity for something else, and then just form a equation, and then you
Yeah,
see
see,
left.
actually, yeah, the mathematical aspect in terms of mathematical aspect, broadly speaking, the whole scoring system and the whole probabilistic method is part of MDP since it's a reinforcement learning model. So we are using Markov decision process. So it's a Markov chain kind of neural network. So that is broadly, but in s- much more larger aspect we can go for many different kinds of probabilistic functions we are using. So mathematically it is too fast to cover everything, but broadly speaking we are using Markov decision process mainly. That is our primary
Okay.
statistics stochastic functions.
All right. Okay. Using the past data to train it for
Yeah,
future
yeah,
predictions.
yeah.
Okay. All right. Good. Nice work.
Thank you, sir.
Thank you.
Any other questions?
I have one question regarding Markov process. Can I speak? Hello.
Hello.
Yeah, we can hear you.
Actually, can you just tell me about? Give me a brief explanation about metropolis hashing.
Sorry.
Hello.
Hello. Sorry.
Can you hear me?
Hello.
Hello.
Yeah.
Actually, I want. Can you just explain briefly about metropolis hashing? It belongs to the Markov precision process. Hello. See, anyone hear me?
Hello.
Hello.
You can
Can
hear
you
me?
hear me?
Yes.
Yeah, I can hear you.
Right now.
Yeah. So you asked about the
Metropolis hashing.
Metropolis Hastings algorithm. You asked about the
Yeah.
Metropolis Hastings algorithm.
Yeah.
Okay. So it's a Monte Carlo method prior to means Markov chain. So Sayan, you want to take this question?
No, I'm not finished with it.
Okay. So
1 minute.
okay, Monte Carlo. In what aspect do you want to know about this? Means in what context?
I mean,
This
I
is a
want
big algorithm,
explanation.
right?
Yeah.
So it's a sequence obtaining model. So what kind of what is your ultimate actual question? Means
What
what do you want to know
what do you
about
want
it?
to do? What do you want to do with it
What no, yeah, actually, in specifically, what do you want?
specifically? Because using the Monte Carlo model as a, I know that is a simple random simplification of numerical
we
result.
are using Monte Carlo. See, we are using here Monte Carlo method. See, Markov in respect to Markov chain stochastic processes, we are using Monte Carlo. So specifically, what do you want to know about means here?
Actually, nothing specific. I just want to have a introduction about it because I'm just learning about it. So that's why I asked. I don't have no idea about how big it is and how expand.
Yeah, it's a good big algorithm. See, it's a important algorithm also.
Yes,
I understand.
here we can using it whenever I said on the previous slide, some slide I said that it based on that's in the slide cluster-based method. So using the cluster-based method, we can identify the features and we can define or we can differentiate two from the using the two features. So on the differentiation, on the process of differentiation, we can using the Monte Carlo method. in aspect to that.
Okay, specifically, I want to say about what you asked.
I mean,
on-
can you just, I mean,
I want
can
to
it be
say
used
something.
in this model? Yeah, yes.
Yeah, obviously it is used in this model. Actually, this method, the Hastings algorithm is used. You see, in Q learning, we have come across a certain term called as Q value, right?
Yes.
Yeah,
So the
yes,
Q
yes.
value, it's a sequence generated value. So the Q value is evaluated using this method. See, there is another term here which Shayanda has used. See, that term is known as, in the next slide, please. In the next slide. Yeah, here the term has been used known as the previous one. Yeah, term has been used known as the positive false discovery date. No,
PFDR.
Yes.
PFDR.
that is determined. That is determined actually by using this Hastings algorithm, Hastings probability distribution. Right, it's a sequence, basically sequence modeling run on random samples. So yeah, it's an adaptive rejection sampling method. So that is this in here to determining Q values, we basically use this algorithm.
Yes.
Okay.
Yeah.
Thanks.
Yes, actually the PFDR or the positive false discovery rate actually basically that is a statistical function to define the expect proportion of the false positive among all significant hypotheses. Okay, so to differentiate that is basically to a clustering between the positive and false negatives. So in this inside it, so the Monte Carlo is already implemented.
Okay.
Okay.
Thanks.
Okay. Any other questions?
Okay, someone asked me that there are various libraries for taking English vocabulary. So, okay, what is the library? So, you can use NLTK. NLTK is one of the good library in Python modules where you can check the wordnet, where you can check the POS, parts of speech tagging, and all other sentence related documentation. They also have large data set. And apart from that, I can remember about a text blob.
Spacey. You can use Spacey.
Spacey or text blob. Text blob also has a rich libraries inside it. So for using or for implementing this using Python language, you can use NLTK and text blob. Okay, any other questions? Okay, one more question. Someone asked about how they select words as noun, verb, etc. Okay, so as I early defined that there are POS tagging, parts of speech tagging. Apart from that, there are also be a use of word or wordnet or word bag of words, or you can dictionary. Using the bag of words, you can be noun bag of words, positive bag of words, negative bag of words, and various kind of. And using the dictionary, you can identify that whenever you look into a dictionary, you can get that is the noun, that is the pronoun, that is verb, and etc. So
it's nothing but a predefined data set.
Predefined data set. That is predefined data set. So we can identify the POS using the predefined data set and POS tagging. That is the method.
Or there is an alternative model. We can use perform topic modeling based on. We can give a model. Say we can say that this is a noun, and these are the characteristics of a noun. Now, the model you find out what are nouns, how many nouns are there. We can also do that, but that is much more crude. It's better to train with the predefined data set.
Yes.
Hello.
Yes.
Yes, sir.
Hello, Sayan.
Yes, sir.
Sayan, I want to mention one. There might be some particular typo in your slide.
Yes.
If I am not wrong, that is in LSTM. Full form of LSTM is long short-term memory. It is written wrongly. Okay.
What
so
it is written? Long short-term memory.
SORT.
Short.
Oh,
Yeah.
Okay.
It's short-term memory. Yes. It's a silly
Okay.
mistake. Yes.
So it's a typo. Okay. So okay.
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 Missed it.
Okay.
There's actually one more. Starting में it was closer, but it should be cluster. It's fine.
Some of the typos, if we try to negate all the
It's
typos.
fine.
Yeah.
Acha, about WordNet, I want to discuss one thing. You said to use the NLTK for like checking a word if it is in dictionary or not, right?
Kind of.
Hello.
Hello. Hi. Yes.
WordNet is basically a database. You see, it's a lexical based database. So, it's kind of a dictionary.
Kind of.
Kind of a dictionary.
So
Kind of.
like like I have used WordNet and I have faced a problem like country names. Let's say Africa, America. These are not counted as dictionary words in that sense in WordNet. If we use WordNet, these words are not getting involved in dictionary, which is a problem with WordNet.
So to overcome this process, you can use other purpose, or you can use you can build your own database, you can build your own bag of words. That's also be nicer.
Actually, have you seen the recent update of WordNet? In the recent, I know it's a huge problem. We all faced that problem when we started. See that in the recent update of WordNet, actually, this problem has been removed. It's a Princeton. The WordNet was originally designed by Princeton. So so the Princeton actually removed this problem in the recent update.
Yeah.
Actually, I used
This
it
update
like
was
a month
mentioned by
ago.
many people.
Yeah, I used it like a month ago, and it was there. So I haven't updated it. Maybe the package was updated. Then it couldn't
Okay,
be
so
solved. Yeah.
you can update it and check if it's still there. Then I think it is gone, because as per the information available in the internet, it is this problem has been removed. So let's see, or you can use different. You can actually relabel them, which is much more difficult. Relabeling a entire data set is very difficult.
Yeah, even more and more words are getting added on lately.
So in that case, since it's a
Yeah.
country based, your problem is with country, you can perform a k-means clustering based on country. You tell the k-means algorithm that these are the
Like
features.
I have
common name
seen
of
if it is only about country running on a document, it may be
Yeah,
it can be that some other words are also getting missed out with this WordNet. So I have figured out that the country names are not getting counted in this. So like running a k means is like for base like it will center pivoting to the words with country names.
Yes.
As Sayan Bhaiya said that we can use bag of words. So like that would be problematic too because there are so many words.
Yes. See, bag of words is a very old technique. So now currently, obviously, it is used everywhere. But then also, bag of words, I would say it's a very old technique. According to me, it's a very old technique. We need revision on that.
You updated me regarding this. Thank you for that. I'll just see if the package is updated or not.
Yeah. Please.
Yeah. Okay. Thank you.
Okay, thank you.
You're welcome.
Actually, I have one question. Somyajit or Sayan. Is there any kind of MNIST dataset or
Yes.
words actually?
Any kind of
MNIST dataset for words. I mean, there are MNIST dataset for symbols or objects, physical objects, real world objects. Is there any MNIST dataset for words? MNIST.
I'm not getting it. Okay.
I think there is an MNIST dataset for words in Kaggle. You can check.
Okay.
I have seen one. That's why I'm saying.
Okay. Which one will be better? WordNet?
MNIST dataset is also better.
MNIST obviously is better.
MNIST dataset is
MNIST is pretty good.
Okay.
But WordNet has been popularly used, and it has been
Yeah.
expanded so much
Yeah.
by Princeton that it is
Yeah.
almost like a huge data system. It's a huge database. So
Anything can be performed.
yeah.
Yes,
In that
yes.
sense,
Uh,
it is also great.
okay.
Any other?
Hello, Shan.
Yes, sir.
Uh, Sayan, so its time is almost 1.5 hour
Ye-
completed,
Yeah. Okay, so let's wrap up.
I
Yeah.
think we are running out of time.
Yes.
So let's
Yeah.
take these questions offline. So put some mail address or something else so that other people, those who want to communicate much more regarding those topics, all those things, so they can communicate later also with us. Okay, so for the hopefully all of us, we have enjoyed a lot regarding this particular question answer session also, and definitely we will go forward on this particular topic later also. So let us pack up this particular session right over here.
Okay, so
Okay.
thank you for
Okay.
everyone. And I
Thank you,
will,
everyone. Okay, yeah.
and the communication link was on the banner. If everyone has seen this banner, you can get our phone numbers and also the email addresses, so you can easily reach there. Apart from that, I already sent you the invitation mail. In here, you can write it back. I will get it mail.
Yeah, and also everyone is welcome to join Brain. So we need researchers, we need young minds, so that we can proceed with our research. There are a
Yeah.
lot of topic we are researching on. We'll say that when you join. So yeah, thank you for the
Yes,
session.
and if you
It's a
want to work on the development phase, you also can. We are welcome the open source developers on the Bread and Code team. So if you want to do anything on the open source, you are going to do anything with any experiment with the code, you are always welcome. Thank you. Thank you very much.